Hello, everyone. Welcome. Good morning, good afternoon, wherever you are. I'm sure you have enjoyed some of the great sessions in the morning of the IBM Tech Exchange Dev Day 2025. And next, Bruce and I will take you through the AI on IBM Z and LinuxONE hands-on experience, right? And we will do it in our IBM LinuxONE Community Cloud. So first, let us briefly introduce ourselves. I'm Alex Sachi, Solutions Architect. I'm part of the IBM LinuxONE ISV ecosystem, work with different ISV partners, help them build their solutions on IBM Z and LinuxONE stack. And yeah, I'll let Bruce introduce himself.
Yep,
And
very
then
good. Hi,
go on.
everyone. Welcome. My name is Bruce Gilks, and I am a cloud architect as well as the leader of the LinuxONE Community Cloud. And so I manage all aspects of the LinuxONE Community Cloud.
All right, thank you, Bruce. And yeah, let me first outline the agenda. Bruce and I will take turns. We'll present different parts, and then we'll have in the second half, more like a two-thirds, I would say, right? We will have the actual hands-on. We'll walk you through the actual lab which we prepared. But yeah, we'll start with introducing you to the IBM LinuxONE Community Cloud. We'll give you an overview of the AI machine learning lab that we prepared. We'll share some quick start links so that you can capture them, and they should have been already shared in the chat window there as well in advance. So you can probably start checking, opening those tabs. And then we'll go with the hands-on part of it, where we'll walk you through step by step. We'll sign you up for the Linux One access, right? You'll get access to your own Linux instance running in IBM LinuxONE Community Cloud and actually running on the IBM LinuxONE machines. After that, that RHEL VM instance will be provisioned, and that's going to be the S390X architecture. Bruce will show you some commands you can run to actually see that the architecture is indeed S390X, right? Because at first look, you may not actually see that right away. Linux will just appear as a normal Linux. And then after that, we'll pull down the AI/ML container for the lab, which includes a lot of packages for AI machine learning and demos, and also the web-based Jupyter Lab IDE. I'll walk you through those steps as well, and you will bring up your own instance of that container, and also your own copy of the frameworks and demos, which then after that we'll just step through. Like there are several sample notebooks, but we'll basically go through step by step through one of them, which will be the AI machine learning fraud detection for credit card transactions. All right, and yeah, I think we'll start with the LinuxONE Community Cloud overview, and I'll let Bruce take over for the next few charts.
Okay, very good. Thanks, Alex. So the platform we're obviously working on is LinuxONE. So we have a joint project with Marist University in Poughkeepsie, New York, where we host a large enterprise-grade Linux environment. And the design there is to make it accessible to essentially anybody in the world. We have participation from pretty much every country in the world. When you sign up, which I'm going to show you a little bit later how to do that, you'll get access to a Linux virtual machine. You'll get it for an initial 60 days, and then you get the option to extend it another 60 days. So that's a total of 120 days. We give you one virtual server with 2 virtual CPUs, 4 gig of memory, and 50 gigabyte of disk. This is usually enough to get you started and to do what you need to do. We have Red Hat, SUSE, and Ubuntu on the platform. You also have the ability to sudo into full root during your SSH session. So this really opens you up to be able to do anything you want to do on that Linux server. We keep this available to anyone 24/7. The registration is fully automated end to end. And we have a browser dashboard, which I'm also going to show you on how to start and stop and create and also delete a server if necessary. And the link below there is our starting page. That link is also in the chat or has been made available to everybody. So next slide, Alex. Yeah, so these are the links. I'm just going to walk you through them. So The first link is kind of our landing page. So if you go there, it's got a number of different tiles on it. There's some interesting things. In the upper right-hand corner of the screen, it says Try Linux Virtual Machines. So when you get to that landing page, you want to click on that Try Virtual Machines on the LinuxONE Community Cloud, because that's what you want to use for this particular lab. And then that'll take you into the registration URL. If you want to skip that and go directly into the registration URL, that's the next one down. That'll take you right to the form to register. When you are registering, if you could please use the event code devday25. So it's at the very, very bottom. And you could just type that in the way it's here, and this will fast track the registration. And it will also give you a server that's a little bit larger than our standard one, so we can go through the AI labs. And then once you are signed up and you have your account, the dashboard link is there. That's where you'll log in and out, either during this session or later if you want to work on it. And then one more thing I want to just point out is we have a fast start guides. It's a tile on the landing page, and it's nice because it gives a number of different short labs and tutorials, so that when you come back and you want to do some more work and you're just interested to see what can I do with the LinuxONE server, this will take you through the real easy walkthrough. So I think with that, we'll shoot back over to Alex.
Yeah, great. Thank you, Bruce. And yeah, those links, yeah, I mentioned already, but yeah, those links have been shared in the chat window. So yeah, feel free to look there and just copy from there. Then the lab environment, which we have prepared, right, has actually a number of AI machine learning frameworks and sample notebooks. It is hosted in the LinuxONE Community Cloud. As Bruce kind of introduced you into that one and how to get access to it. So the lab is hosted there. So there we have some GitHub pages with steps and detailed kind of steps and guides to walk you through how to bring up the lab onto your instance in LinuxONE Community Cloud. The lab actually covers a broad range of frameworks, right? It has PyTorch, Tensorflow, Keras, SciKit-Learn. It's packaged as a container, and there are two options of container runtime that you can use, either Podman or Docker. There are also options of Linux operating system that you can use, either RHEL instance or Ubuntu. So you will bring down, actually configure, set up your RHEL instance, for example, or Ubuntu. Then you will bring down Podman runtime or Docker runtime, and then connect to the registry, which we have a local registry in the community cloud. It will pull down the container image onto your system, and then you can start it up. Once it's started, right, it provides you a nice user-friendly web interface, so you can just interact with your container and your instance from that point on. Once the container is up, right, you can interact through the Jupyter notebooks, right, which is a web interface. And we'll do this all step by step, right, in the second part of the hands-on. One of the sample notebooks, and that's the one we'll be actually going in detail, is the notebook for credit card fraud detection, credit card transaction fraud detection, right, with AI machine learning. And specifically in the example, we use LSTM model, which is a long short-term model. It's a deep learning network model, which is good for detecting patterns in the series of events, right? A series of transactions. Yeah, it has multiple layers. Each layer has a number of neurons, right? And a number of parameters and weights and connections and so on. Then there is a sequence of transactions, right? And we have a sample transactional data, which comes with that demo notebook. And let's say you have a sequence of transactions, and there could be a different fraud patterns in it, such as, let's say you have maybe the card has been always used for small transaction, then suddenly a big transaction, a big amount transaction occurs, right? In this case, the model will be able to detect and say, okay, well, this transaction is a fraud, right? So you'll get an output that, yeah, that transaction is labeled as fraud. Also, just to give you some context, right? Recently, we had The latest generation of IBM LinuxONE 5 was launched last month. It's out, so it offers now an accelerated and increased capacity for AI acceleration, right? So it's a new IBM Telum II chip with AI accelerator. You can scale actually into multiple of those chips, right? The chips within the drawer, we have an intelligent routing. And then if you need even more capacity, you can scale within the same system, right? You can add Spire card accelerators and scale actually your models even on those, right? And again, like if you look inside of the deep learning models, you can see that, yeah, there could be many layers, right, in the deep learning network, right? So you need capacity to run those layers. Each layer can have hundreds, thousands, millions of neurons, right? So, and also like you need that capacity, right? If you have the model, the bigger the model it is, you need more capacity, right? Acceleration on the hardware side to do it. And this is where, like, yeah, we have LinuxONE 5 really well positioned for this type of acceleration. All right, before we start the hands-on part, let me share the key important links. There are two major parts, right? The first part is the LinuxONE Community Cloud sign up and also provisioning of your Linux instance. And this is where Bruce walked you through the setup and provisioning. And for those of you who've joined the previous session, maybe the session by Lise Joseph, right, and has completed already the first part, you can actually skip the first part and maybe go straight to the second part, which is the actual Jupyter Lab machine learning container. And just there is a link there. It's also shared in the chat window. So you can just skip the first part and go maybe have a head start and proceed with the second part, while we will walk everybody else through the part one, signing up in the community cloud, getting the instance ready, and catching up with you maybe on the second part a little bit later. All right, with that, I think we can move on to the hands-on part, and I would let Bruce take over the screen and kind of, yeah, walk you through this.
No problem. Yeah, thanks, Alex. Yeah, so I'm gonna walk you through the basic navigation as to how you get registered, bring up a SSH session, and just run through a couple commands to show you what's going on. So one thing I want to note, in Alex's previous chart, the event code is actually incorrect. So in this chart is correct, dev day 25. In your previous chart, Alex, you had dev day 2025. Oh, okay. So no big deal. I just want to make everyone aware of that. So it's dev day 25 for the event code.
Yeah, I'm glad you got it, Bruce. Yeah, thanks.
Yep. No worries. Okay, and so from there, if we can switch over to me, and I will start the demo. Okay, hopefully everyone can see my screen. We should be looking at a web page that says getting started with IBM LinuxONE. This is the first link that I mentioned. So these are all the different tiles. I'm going to click the one that I instructed you guys to, which is the try virtual machines on LinuxONE. And that will bring up the registration page. If you want to skip to this, there is a link that goes directly to this. So just type in my email address. And password. Put my name in. I'm with IBM, my country of origin, and a brief description. I'm just going to put test, we'll say demo, demo for the day. Okay, so the description, while it is mandatory, I just want to say we actually read this and we go through it and we look at what people are doing and we try to make things better based on that. So it's important that you give us a good idea of what you're doing. It really helps us to make things better going forward. The event code down here is dev day 25. This will help us get through registration quickly and also provision a little bit more memory, which we need for this specific demonstration. Okay. So we're not going to remember that. Okay, so we get a message that says, thank you for your registration. You'll receive an email shortly. That should just take a few seconds to come through. There it is. So we get our first email. This is really important, and you need to activate your account. So we get the first email. We go in, we click our activation link, and we activate our account. We also get another good message that says you're ready to go and sign in. And so if I click the sign in button, I get my user dashboard. The credentials are the same ones that I entered into the registration. Linux 1, 3. Okay. And I'm going to sign into my dashboard. Whoops. I might have missed. Yep, I mistyped the email. Try that again. Okay, so that brings us into our first part of the dashboard. These are some informational links down here. What you're looking at is the service catalog here. We're going to click on Manage Instances. There's a guide as well, which has some good information and some links and things like that if you want to check that out. But we want to go right to creating our first server. So we go right into our dashboard. We have a quota of 1. We are going to click on Create. And I'm going to give it a name. It doesn't matter what it is. I'm going to choose my distribution. I believe, Alex, you said to choose either RHEL or Ubuntu. I'll do RHEL, and I'm going to choose my flavor. So you'll just have this one size flavor. This will work well for the lab. And then once we're here, we need to create an SSH key pair, right? So we don't log in with user ID and password. We log in with ID and a key. So create that key now. You do have the ability to upload your own public key if you already have a private public key set up for yourself that you use. But I'm going to go ahead and create a new one. Usually that's the easiest way. I'll put that here, save that there. And then once I've saved it, this went gray again. This sometimes trips people up. You want to go back in and select that key that you just created. And then we click Create. And this goes off, and you'll see it generating and whatnot. So this takes around 5 to 6 minutes to create a fully functioning server. So what I'm going to do is I'm going to bring in, I have a server that I've already created. So what I'm going to do is I'm going to log out of this account, log into another account. Okay, so I logged into a different account where I've already created a server. So once the server is done, it'll look like this. You'll have the active status here. You can click the details on it here. It gives you the size of memory, the virtual CPUs, the disk. The image name is RHEL 9.3. When we provision these instances, they go out and get all the latest updates and latest kernels and all of that. So it's actually RHEL 9.6. We just need to update that name. So that's what it looks like once your server is created. You can stop the server, you can start the server, you can delete the server. If you host yourself up and get locked out or whatever, you can always go back to your dashboard, delete the server, and create a brand new one. So with that, I will bring over my SSH session here. And a second, there we go, size it right. Okay, yeah, so I'm going to use a key that I had made for the server earlier, log into the IP address, which is in the dashboard there. And once I log in, I'm now logged in to IBM LinuxONE, which is really cool. And let me just run through a couple of commands just to show you what we're running on and what we're doing. So this release command, this just shows you what release of Red Hat. As you can see, is Red Hat version 9.6. That's the latest version 9 level. This is another command here. The proc version, this gives you your kernel version, the GCC compiler version, and some other information as well. And you can see in the kernel, it's got the S390X on the end of it. This command, this is the sysinfo commands. Let me scroll back up to the top, and we can see that we're running on an IBM. It's a mainframe type 8561, and the exact model number. The entire mainframe system has 145 processors, and this is information about each of the processors. Not too interesting. And then we're running on top of the hypervisor called ZVM, and we're at the latest level of that, which is 7.3. So this gives you some pretty good information. There's another one which is of interest, and I'm going to skip to this one. And the top command. So the top command will give you just, real-time resource usage and who's using those resources. When you're in the top command, if you press the number 1 key, it'll break out those 2 virtual CPUs from one number into 2, so you can see how those CPUs are being used. I'm not doing much, so we don't see a whole lot of resources being used here. Memory's down here, any swap is down here. So top is a nice command to understand what kind of resource you're using. If you want to really drill into the memory, the vmstat is a good command as well. It's not real time, although you can put it on a timer and have it update every 5 seconds or whatever. But the vmstat just kind of gives you a snapshot of the memory, what's free, what's in buffer, what's in cache, and all of that. So that's another nice command. And then I guess the best command is the sudo command, because this gives you root. Oh, what did I do? There we go. So this gives you root authority. So I do a who am I? And I am indeed the root user. So be careful with that command. Obviously, you can do anything you want to inside of these Linux instances. And as root user, we give you that power. If you break something, like I said, you can always go back to your dashboard, delete the server, or restart it, or whatever you need to make a new server. So I think for me, that is it.
Yeah, that's great. Thank you, Bruce. And always people always find it amazing to see that when they do ls CPU command that the processor speeds are like 5.5 gigahertz, right?
Oh, that's true. Yeah.
Unlike any other servers. Yeah. So definitely, those are really nice, great commands to kind of dive into the depths of the Linux. Okay, let me go ahead and share my screen here. So the next part, right? So we will install the Podman runtime, and I'll log into the RHEL instance that Bruce showed you how to provision. I'll log into that through SSH, and then we'll install the Podman container runtime. And after that, we'll start the Jupyter Lab container, right? Which will be then exposed and accessible on, let's say, your IP address instance through the port 38888. Right? All right. Okay, so I'll use an SSH command, get to my RHEL instance through SSH. And then similar, like you saw in Bruce's case, right, I'm logged into the LinuxONE instance in the LinuxONE Community Cloud. So here I'll just go ahead and install the Podman runtime using the sudo dnf install podman command. And it's doing the installation. What's notable here, right, and that's what also kind of catches people's attention, right? The RPM packages, right? They have the architecture, processor architecture in the name here, and you can notice that this is an S390X architecture, right? That kind of tells you that this is not like an AMD 64 or ARM processor. This is an S390X architecture processor, which is the mainframe architecture. So otherwise it's Linux as you know it, right? So Podman, installing the Podman, it just shows you like from RHEL, just a standard command. It shows you which packages it's installing, dependencies, and it does the installation for you. All right, it's complete. So we can do something like Podman PS, right, to make sure Podman is running. You can also start it as the daemon. By default, Podman doesn't run as a daemon, so you would need to, like we have an instruction, you can start it optionally as a daemon. But we'll actually go ahead and move on with the container. So the command I'm running right now is to create a shared folder, right? This is the folder which you will use to exchange files with your container, Jupyter Lab container. And you want to make sure this container is accessible. That's a command. We got that one running. The next prep step is to enable the port through IP tables right in the firewall. So we need to open the port, which is 38,888 port, right? Make sure that it's accessible so that you can connect it from your computer through a browser. And then we're gonna run the actual command to start the container. So here you can see we're launching the container from the local registry. We also pass in as environment variable, we pass in the token, right? In this case, it's just your token, but you can feel free to modify to your own password, right? This is like going to be your secret, how you log into the instance. And it will pull down the container. But part of this podman run command, right, which is similar to Docker run, right, depending if you use podman or Docker, right, we specify the port, right? The external port is 38,888, internal is 8,888, the name, and then we mount the local folder, right, which is the shared folder we created. We're mounting it to the inside of the container, so it's accessible under this bus inside of the container. And it should take just like a few moments to bring down the container and unpack it, right? And again, the container has a lot of packages. It has pandas, it has scikit-learn, it has PyTorch, and all the popular open source popular AI machine learning packages in it, plus Python runtime, of course, and Jupyter Lab. And yeah, here, like we have also, like we specify the image, right, which is a local registry, pulling down the container from the local registry, specify which token we're going to be using with the container. All right, I think it's getting close to the completion. While it's running, let me give you a quick preview maybe of what else we will be doing. Switch to the presenter view here. So once the container is up and running, we'll just open the browser, navigate it to the IP address, like your IP address here. You'll put your IP address and then the port. Then as a password, you specify the token, which was passed into the container. Then in the browser, right, you'll put in the token here. Once the token is in, it will come up with the, you'll get access to the Jupyter Lab interface, which is a web browser-based IDE. And this is a pretty popular IDE amongst data scientists because it allows you to run Python code for your AI machine learning with annotations. You can run it step by step, and that's what we'll be using. We provide 3 different sample notebooks. One is we show like how the scikit-learn, which is more like a traditional machine learning, can be used, and PyTorch can be used for on like in the credit card business, right? Banks, they may want to determine the churn of their customers, like which customers are likely to stay with the credit card, which customers are likely to abandon their credit card, right? Based on activity, based on other factors, right? And then machine learning, like random forest model, help them to score each customer, each user of credit card, and kind of provide the score, the churn rate of that specific user. Another sample, we just show the typical classical kind of problem of image recognition, image classification using TensorFlow, right? In this case, it's like a handwritten needs the data set of digits, different digits, 0, 1, 2, 3, and so on. And then using the CNN neural network model within TensorFlow to recognize those numbers, right? Running everything running on IBM LinuxONE. And finally, there is another sample, which is the credit card fraud detection, and that's the one which we will be actually going step by step in this session here. And basically leverages LSTM model which runs on TensorFlow Keras, enables fraud detection by detecting for each for a series of credit card transactions. We will be detecting whether there is fraudulent transaction or not. Okay, let's see if this has been completed. Yep, the image has been pulled down and the container must have been started. Let's do a quick check. We can do podman ps again, right, to see. And yes, the container is up and running. So we'll go ahead and switch to the browser. Yeah, and these steps are, again, I'm trying to make it bigger here. Yeah, these steps are all documented in the GitHub repo, right? The link has been shared with you, so you can actually follow these steps. We have steps for Ubuntu. In this case, the README has the Ubuntu steps, but also you can navigate just to follow the steps what we do in this lab. You can click on the README URL, and this gives you the steps for Podman and Red Hat Enterprise Linux, similar steps here. Bringing it up. All right, let's see. I hope, yeah, most of people were able to get to this point where you have your Jupyter Lab container up and running, and you can see those sample notebooks here, right? The one that I mentioned, there's a churn notebook using random forest, kind of traditional machine learning to detect the churn of the credit card users. We have the digits recognition, handwritten digits recognition with Tensorflow. It's another sample. And then we have the fraud detection with credit card within credit card transactions, right? This is the actual notebook that we will be going step by step. And yeah, what's good about this lab that we provide you with the data, right? The data is provided as a CSV file. So you can actually look inside of this data. You can see the transactions, right? The actual transactional data that's provided as part of the container. You see the credit cards, the amounts, merchant, where the credit card was used, what's the MCC code, is there any errors, and then the last column is actually the target column, right? The column for training and prediction, which is whether there is a fraud, whether the transaction is fraudulent or not. Okay, so and I think we can get started with the stepping through. I hope everybody already by this point got their systems up and running, and you also were able to access your Jupyter Lab container. So what we do in this Jupyter notebook, we will show how using the Tensorflow and LSTM model, how run it on IBM Z LinuxONE, and how to train the model based on the credit card transactional data in the CSV file. And the same CSV file you can actually get from the kaggle.com as well, right? It's been published by IBM Research, been open sourced. So the same credit card transactional data set is also available up there. Then the data contains some normal typical transactions, but also transactions that are likely fraudulent, right? Or have a fraud label on them. And there are different patterns, right? Usually when it's fraud, there could be horizontal patterns. So per se, each transaction may have clues that this is a fraudulent transaction, but also some patterns are kind of like vertical patterns through the history of the data. And if you use like a deep learning type of model, like recurrent network neural model, LSTM type of model, then you can actually detect both kinds of patterns. We can train it, and then the model will be able to detect both types of patterns, right? Horizontal and vertical, kind of through the data. So it means it will be able to look through the history of transactions, let's say 7, 10 transactions, right? And detect fraud, or actually it can also look like within a single transaction into different fields of the transaction, such as amount, maybe time of the day, location, right, of a specific transaction to see if that's fraud or not. Then we will be transforming the data, kind of making it through this notebook. We'll make the data, prepare it, transform it, prepare it for the model, because different models, AI/ML models, they prefer different type of data, right? All of them prefer data which is clean and kind of uniform, but sometimes you have to also worry about like numeric versus categorical features. You have to think about the scale, the range of each feature, and so on. Then the data set will be split into training, validation, and test data set. And then the algorithm LSTM will be applied. We'll train the model, and then we'll test it and validate, make sure that we get some good level of accuracy. And in this demo, we use a relatively lightweight model, right? So it only has 2 LSTM layers, hidden layers, right? And then input layer and output layer. With each layer has different gates, right? As part of this LSTM algorithm, we have like forget gates, remember gates, learn gates, and use gates, which allow the model to kind of learn through the history of transactions, right? And still remember, let's say, the first transaction while being trained on the last transaction and so on, right? This kind of makes the LSTM model really suitable for these kind of like pattern detection within the series of events or series of transactions. All right, let's go ahead and start. And as I mentioned, this Jupyter and IDE environment is really popular among data scientists because you can just go step by step. Each step is annotated, and you can actually see the output from each step, right? So we click through the first step, we move on to the next step. And this step will set up the environment, right? So we're importing all the necessary packages such as Tensorflow, Pandas data frame, right? And we click through this. And then this step outputs the version of Tensorflow. You can see that it did the output right there interactively, 2.9.3. We move on to the next step, and this is kind of specifies how many transactions in the series we're going to be looking at, right? History of 7 transactions. We're going to load the data set into Pandas data frame, and the transactions are in the CSV file. Then they will be loaded into the Pandas data frame in this step, and then split into 50% of data will be used for training, 30% for validation, and 20% for testing. Then we will generate indexes for each set. We'll use some random selection approach so that when you rerun this again and again, you actually, you make sure that you have a repeatable, reproducible kind of results, reproducible accuracy, while using the random selection each time, right? So, and let's go over this step. Yeah, the step is completed. You can see that this data is loaded from CSV file here, right, in Python code. Then we output some data here, like a sample, like set of columns which are there. You can see that there are different columns like user, card, date, amount, merchant, and so on. And the last column, 14, is the fraud column, right, the target column that we'll be trying to predict. The next step, we will create a test sample. And the way we do it, right, is we take the original data set and then we create test indexes. And these indexes are kind of like pointers. They point onto different transactions in the original data set. So the reason we're using indexes and not like the actual data always, right, is to be more efficient with memory, right, and not to minimize all of the processing, kind of reshuffling, moving the data, splitting the data, and so on. We're just dealing with indexes while the data set kind of remains as is, as it was originally loaded, right? Kind of makes it more efficient, way more efficient. In the next step, we're gonna define some custom mappings. So we're gonna basically configure a mapper which will include a number of transformers. For each column, there will be its own transformer, which will kind of convert the original data, let's say a text column, right? We'll convert it into some numeric representation suitable for the LSTM model. And recent practice has been in general in this data science AIML is you have your pre-processing and your actual model combined into one pipeline so that you train both pre-processing and you train your pre-processing or your model like at the same time, right? So you don't have any more like separate steps of, let's say, pre-processing, like you prepare your pre-processing, then you train your model. You actually combine those into pipeline and then you just train both in like lockstep where you have where you actually making sure that the both are trained on the same data, both are tested on the same data, and it kind of becomes like one package, one pipeline, right? So in this case, we're going to define different mappers here. And yeah, there are some encoders, like for example, we need to do encoding on the time. We need to do encoding on the amount, right? Because the amount is like a dollar amount. We need to kind of convert it into some float number. We have decimal encoder, fraud encoder, right? So fraud is in our original data set, you noticed, right? Fraud is marked, the column has like yes and no. So if you take just yes and no as it is, it's not going to be suitable for LSTM models. So we need to encode it as 1 and 0, right? Make sure that, you know, we do the encoding of yes and no into 1 and 0. Right? So we configure in that pipeline. And then next, we're going to do fitting, right? We're going to fit the preprocessing function using the data mapper. Yeah, and it has been completed. You can see that each column here, when we configure our data mapper, right, each column gets its own transformer, right? It's either like functional transformer, or we have our function fraud encoder doing the transformation like yes and no to 1 and 0. We also use some standard encoders like merchant name, merchant city, right? Like city also is a text, right? It's a categorical feature, so you want it to be encoded into some numeric representation, but there are some standard encoders like labor encoder which will do the job for you. We'll also use the one hot encoder as well here, right? So which will help with kind of spreading the data, make it again suitable for this specific type of model that we are using. Kind of yeah, expands the data for us. It's rather than just using a simple number, it actually creates a matrix out of it. We use some simple imputers and label binarizers for things like binary, like errors, chip, yes and no, right? True, false, right? Becomes like we're using label binarizer encoders. And this all composes our data frame mapper, which will be part of our pre-processing step, right? Yeah, so we are moving on. This could be serialized, so you can actually serialize and save your mapper into a file and then load it back later. Next step, we'll just do a one row transformation, right? Just to kind of see how the pre-processing works. And it shows that yes, we were able to pre-process it with 190 values. Next step, we're looking into kind of setting up some helpful functions and classes, which will help us to kind of prepare the data further and prepare the model. We'll define and compile the actual model with Tensorflow. And yeah, the model needs to be defined first, right? So you basically define like the model, and using Tensorflow and Keras in this case, you define, for example, what are the input parameters, what are the output parameters, what will be the matrix, like how many time steps are there, right? Input size. We'll also use like a visualization plot model to visualize the model after kind of building it. And you can see we kind of constructing this model as a sequence of 2 hidden layers, LSTM layers, right? And the dense layer. And once it is built, we make it output like right after this step, right? We made it to output the summary of the model here in this step, and also we made it do the plotting, like visualize what the model is, right? And we can see that yes, there are 2 layers of LSTM, and then there is a dense layer, output layer. So you have here, we also have like a visual. So we have the input layer, right, which is our matrix, right, of 16 features, 7 items in the history, or yeah, and 189 actually 189 features, and then 16 in the batch and 7 in the series, right? And that's the input layer. Then we have the 2 hidden layers, which will be our actual model and network. It will be trained. And then the output layer, which will do the kind of translation and output, right? The output will be 1, which is the prediction of the fraud, yes or no, right here. We'll move on. We get the next step of compiling the model. So once the model is built, we're compiling it. Then we need to generate, like before we start training, we need to generate some training batches, right? So we create a generator so that dynamically we can generate batches for this. Then after that, we are ready to start the actual training. And as you can see here, we do the training by calling the model, which was built and compiled, by calling the model and saying fit for this model. We have our generator for the data, we're passing it in, and we specify that we're going to be using like 5 epochs here, which is like the 5 iterations of training. And as we go on through the first one here, you can see that the accuracy is getting better and better, right? We have like 0.93%. So after the first epoch, we got 93% accuracy. So we're doing the second one, and second one, you already see that the results are much better. It's already getting up to the 98%. Yeah, we're going to be doing a few more. Yeah, something important to note here, right? So these kind of high accuracy numbers look very good. They maybe too good to be true, right? The reality is like you have to also understand that the credit card transaction data set is highly imbalanced, right? So like if while it's running, let us look into the transactions, right? So if you look inside of the transaction history, the data set that we are using, right? The last column here, fraud prediction, most of the transactions are non-fraud, right? So that means the majority class is fraud equals no, right? Minority class is fraud equals yes. So you have let's say 95% of transactions in the data set which are not fraudulent. So then when you just training model like this, and we're just doing it for demonstration, but in general, right, when you're training this model, you need to understand that yes, you even if your model just predicts everything as non-fraud, right, you will already be at 95% accuracy, because 95% of records are no fraud. So it means your model just without doing any actual predictions, right, will be already 95% accurate. So this is something also like that's where it's important to understand what is your data, what is your data set, right? And yeah, we're getting pretty high numbers, right? With each epoch, the accuracy is increasing, which is good. Now we're getting the 5th epoch, and the accuracy is already at 99%, right? You can see it was progressing from 98.986, 98.8, 98.9, and then getting all the way to 99%. Yeah, with more balanced data sets, like if we had like an equivalent number of fraud and no fraud transactions, maybe like 50%, right, then the accuracy wouldn't be this high. The accuracy would be probably more like 70-80%, right? And then you have to like continuously improve it in order to get to the 90% areas, right? All right, so we got that step completed. Then the next step is, yeah, we want to use the generator for testing, right? In this case, the test batch generator will be prepared. Hold on, yeah, this step is not fully done yet, I guess. Okay. Oh, there we go. Yeah, we're still wrapping up, I think, the model from the previous step. So yeah, while step is not executing, you will see you can see that there is asterisk there. That means the step has not started, or maybe is still running. Okay, now once it's completed, you will see the number of the step, which is 18 in this case. The step is completed, so we moving on. Okay, I guess I accidentally click on the same step, so it's rerunning it. Okay, we can just stop this here. Yeah, accidentally click on the step to rerun it, and that started training again. We don't want to do that. All right. So we're gonna do the test here. So the model that was trained, right, will be testing in this step here. And yeah, we take like a smaller batch. That original data set that was split, right, is now being used for testing. The data which hasn't been seen before by the model, right, is used for this step. And as you can see, the accuracy is already pretty high. So that means the model is actually trained pretty well, and it's not overfitted, right? So on the new data, it actually shows equivalently high accuracy as before, right? So even this data has not been like used in training, right? It's like a new data to the model. That subset of transaction, that 20% of transactions we hit, which we haven't used in training. Yeah, they actually showing pretty good accuracy here as well, right? 99.2% accuracy. And that was a quick test. Now we're doing the full test, basically getting a larger data set. And while it's running, let me see, I can probably give you a preview of the next step here. So once you train the model, right, you can export it to the ONNX format. And ONNX is an open neural network exchange format. So this makes your model kind of compatible with other platforms and backends, right? And ONNX is in like open source format, so it is designed for interoperability across different deep learning frameworks, right? So you can actually, exchange the model between different learning frameworks, different platforms. So it means you train your model, pretty much you can train it on Tensorflow, you can train it on PyTorch, you can train it anywhere, you can train it in the cloud, you can train it on your laptop, right? You can train it on computers, any other computers or GPUs whatsoever. And then you export it to ONNX format, and then you can actually bring it onto IBM Z and LinuxONE, right? So the flexibility which we kind of provide and promote, right, is that you can train your model anywhere. It can be also on LinuxONE, but doesn't have to be, right? So you can train it anywhere pretty much. And then you export it to the ONNX format, and then we have a kind of compiler mechanism, compilation, the deep learning compiler, which helps to compile and execute it and leverage the AI accelerators that we have in the IBM Z and LinuxONE. So you basically export it to ONNX format, then you deploy it onto IBM Z and LinuxONE, and you can then run it for inferencing in your production and in different production workloads. Then for the model that we just trained and tested, right, the accuracy is great there. So we can just go ahead and export it to ONNX format. So in this case, we're going to use like Tensorflow to ONNX package, and we just execute this step. And as you can see, this just takes our model and saves it into the ONNX format file here. The model is, a little bit large. That's why it takes maybe a few moments to save it. Okay, now it's complete. And we should see the file appearing. Yeah, you can see this file appeared here inside of the Jupyter Lab IDE. Yeah, we can click on it. This format is encoded, but so that's the file which is now saved in that shared folder. So you can actually get access to it from your Linux instance, and you can transport it wherever you like it to, right? But yeah, this kind of demonstrates you the concept, like train anywhere, export to ONNX format, interchange format, and then you can deploy it on the IBM Z and LinuxONE to do for the inferencing, right? To do the inferencing, because usually like training the model, working with the model, right, is kind of like an equivalent of, let's say, developing like a software, right? So you have your developers doing coding on their laptops. Maybe some developers use some cloud IDEs to develop it. So in this case, your data scientists work in their IDEs and their systems. They do development of the model. They build it, and once the model is built, that's when it's ready to be deployed to run in production as well. So, and the similar kind of approach is also supported here for models. All right, and I think that concludes this hands-on part. I hope everybody was able to catch up. If not, again, you should be able to go back to the to the GitHub and follow the instruction here, and maybe you'll find the step where you are at, right, and just follow the steps after that. We also have like some comprehensive FAQ. So if you ran into an issue, right, we have like a frequently asked questions section. So you will be able to find, and this has been like, yeah, created over time, numerous events and hackathons and so on. So most likely your problem has been already kind of noted, experienced, and you would find an answer and solution here. Yeah, there are different FAQs, frequently asked questions. Okay. Otherwise, yeah, let me bring up the links again. And we can see if there are any questions that we need to answer. So yeah, these are the important links, right? So again, registration, the first part is registration on the community cloud. Then the second part is getting your AI/ML lab as a Jupyter Lab container, and running some demos, including the demo data and everything that's part of it, part of that container.
Now, Alex, just a quick note. So if a user failed to put in the dev day 25 in the event code, that's okay. If they did not do that and they are not getting the email, the activation email for registration, they can just email there's an email address all over our websites. It's Linux and the number 1. So linux1@us.ibm.com. I'll put it in the chat, and they can just email that email and let us know that they were part of this and they have not been approved.
Yeah, and I see some questions, right? Some people were actually still spawning an instance, and yeah, Bruce mentioned, right, it takes sometimes 5 to 6 minutes, right, maybe to bring up the Linux VM. Again, it depends also, maybe multiple people going at the same time, right? And maybe
yeah, that will
like
slow things down just a little bit. Yeah,
right, maybe like 10 minutes, maybe that's where occasionally it may spike there. But then again, yeah, if you couldn't, like, I hope at least you could follow the actual presentation, right? And so me going through the steps and Drew's going through the steps, right? So that should kind of like give you an idea. And now you can just probably, wherever you got lost or stuck, you can just get to the GitHub documentation and like resume from the step where you got stuck, right? And continue and just follow the steps there. All right, so yeah, looks like there are no other questions. Yeah, feel free, like Bruce also shared an email, right, to reach out if you run into any issues. Yeah, feel free to reach out to us. Yeah, otherwise, yeah, thank you everyone for joining, and yeah, definitely enjoy the Dev Day and Tech Exchange and all the sessions that are still coming. And although there are some, I think, more hands-on and more kind of hacking opportunities will be throughout next days. All right, thank you very much.